If you are working with large or medium large size data set in MATLAB, then this video would help you a lot. Many times happens that you need to find maximum value from that large data set or minimum value from that data set, or some logical values like values in between 0.5 and 1, values greater than 0.8, values less than 0.4, or any numbers of logical values you want to extract from that large data set. How to do that? That is what we are going to learn in this video. So without wasting time, let's get started. Okay, so now first we'll prepare the script for this data extraction. This is the script of my previous video where I have explained a standard matrix multiplication and element-wise matrix multiplication. If you are new to MATLAB and learning MATLAB, then this is very important to know. If you want to know, then you can check out those things later on. Right now, let's prepare a new script. We'll start with CLC. First, we'll import a large data set. Let me show you a large data set. For example, this is the large data set that you are working with, or this could be even larger than this, 10 times, 100 times larger data set than this. Size does not matter for now. So what we'll do, we'll import this Excel data to our MATLAB and then we'll work on that. So now let's jump to MATLAB. Okay, so there we go. We have imported that Excel sheet to MATLAB. If you don't know how to import Excel sheet into MATLAB, then you can check out this video. There I have explained in detail how you can import each and every column or multiple things in Excel sheet, right? So right now we are not discussing that thing. So first here you can see this data is in table format, right? Double click it and you will be able to observe this data in table format, right? So we do not want this, because for our process we want the data in double format. So first we'll change the data type is equal to. With this command you can change the data type from table to array or a double data type. Run it and it will ask you to save. I have saved it and then run. So here you can see all the details are same, but now the data type is converted to double. Now we can work on that. This is our entire data set, right? So now let's close it. Now directly if I'll explain you with this large data set, it would be tough for you to understand. So what we'll do, we'll take one more data set. Let's make it like this. And we'll suppress the output every time. We do not want this large data to appear on my command window, so we'll suppress it and run. So we have another matrix B with this varieties of things. Let's make few changes here, right, so that we can have a real genuine varieties of data. Okay, so now this is our B matrix and this is our large data. So what I'll do, I'll explain you process on the small data set and the same thing can be applicable for the large data set. Now let's suppose you need to find the maximum value from this B. So when you write C is equal to max of B, it will give you the maximum value from all the columns. But what exactly you want? You want one biggest maximum value from entire matrix. But when you just write max of B, what it will give you? It will give you the largest value from the column. So from first column the largest value is 9, from second it's 21, third 17, and in last it's 16. But this is not what we want. We want 21, because here you can see the 21 is the largest number. So for that you need to write max of B, run, and there we go. You have C is equal to 21. So this will give you one single element, the largest single element from the entire matrix. You can do the same thing with other method like CC. This will give you the same result. C and CC will be the same. Run it and you can see C and CCC, they both are 21. So these are the different ways to find single element, the single largest element from the entire data set. Now let's perform the same thing for our A variable. Now we don't want this thing, so we'll remove it. Sorry, we'll not remove it, we'll just make it comment so that you can note it later on if you want. So this D will be the maximum value from A matrix. This is error because I have not closed the bracket, right? It's my mistake. Let's run it again. So the maximum value is 0.9934. If you want to check this whether it is true or not, you can just rewind the video and check that Excel sheet when I'm showing entire Excel sheet where you can see all the data. Now the same way you can even find the minimum value. Let me show you quickly. The smallest value here is 1, right? So this is how you can find the maximum and minimum value. Now let's comment it. Now in this large data set, let me show you this thing. In this large data set, what if you want to find maximum value from only this much of data, right? From column 1 to 3 and row 1 to 5, or any random column you want to find largest data from any random column. This is the area from where we need to extract the maximum value. So how we can do it? Now here you need to specify the numbers of rows and columns that you need to consider. So the row is 7, 8 and 9. So we'll write 7 gem 9, comma, column numbers are 3 and 4. So we'll make it 3 gem 4. Bracket over, another over, and finally over. And let's run. So the answer is 0.9640, and just verify 0.9640. This is the largest number. So using this method you can extract maximum value or minimum value from selected area of the large data set. Now what if you need to find the exact location of that large data or indexing of that large data? For example, here we have got the answer that 21 is the largest number from this matrix. But what if you want the location of that number, that it is situated in row number 1 and column number 2. So 2, 1 is the exact location of that number. So how to identify that location? So now I'll tell you that thing. For that indexing, you can write f, comma, let's say I for indexing, bracket over, is equal to max of b. Run. So here f gives maximum value from all the columns and I gives the indexing. That means in column number 1 it's third element, in column number 2 it's first element, in column number 3 it's second, and here it is third. So it will give you indexing of that number. Now what we aim to do, we need to find the location of the largest number from all these things, right? So again we'll do the same thing. This time I'll make it small I. So now what I am doing, I am finding the largest number from this matrix and then the indexing of that number. So here the largest number is 21 and the index is 2. So now I'll tell you how we'll find the exact location of this 21. Now here h is equal to I of small I, comma, small I, bracket over. Here this I of I gives us the number of row and I gives us the number of column. So this row and column gives us the exact location of our number. So now let's run. H is equal to 1, 2. So row number 1 and column number 2. This gives us the exact location of our number. Now let's do the same thing for our matrix A, the large data set, right? So instead of this B, we'll replace it with A. Let's run. So it gives us the number 3, 2. That means the highest number is 0.9934 and the exact location is row number 3, column number 2. Let's open A, row number 3, column number 2. Here it is, 0.9934, 0.9934. So this is how you can find maximum and minimum data from the entire data set, from any size of large data set. Now initially I have promised you to make a logical statement for the data finding. Find all the data which is larger than 0.8 or which is smaller than 0.8. But the length of this video has already been so long, so I am not covering that thing in this video, but I will cover those things in our upcoming videos. If you want to find data with some specific logic, then do not forget to write in comments below, so that if possible I'll make video on that specific requirement. If you want to learn different things on MATLAB, then you can refer this playlist and these varieties of video on MATLAB tutorial. So until we meet again in our next video, till the time, bye bye.